Alright guys, and we're going to be going over output resistance by inspection analysis in this problem. And here we have the same circuit we've been dealing with for voltage gain and input resistance if you've seen the past videos. And now I recommend you solve this output resistance without watching the video first, then watching the video or just skipping to the end if you want to check your answer, and then rewatching the video if you get something different than me. So what we're going to be doing first is, of course, you have to label your output resistance here, looking in from the out of V out, and then you also have to short your AC sources, any other input sources. So here, you're going to short V in. Now, what does that mean? Whenever you short V in, we're not going to look at R out right now, but we're going to look at what happens to R1 and R2 when you short that voltage source, that AC voltage source. Well, R2 goes to 0. It shorts also. And R1 goes to 0 because it shorts. They're in parallel. So what is the resistance of base 1? Well, it's equal to 0, so it's going straight to ground. This is very important because you might end up having this. This may not be a voltage source. It may be a capacitor. Remember, in AC analysis, you have to short capacitors. So be very careful and be very mindful about what your input sources and what are going to do, as well as your DC sources. Of course, DC I already have here as grounded. Oh, that was supposed to be a delete. I already have the DC sources grounded and the capacitor shorted. So I don't have to like explain it over again in every single video. I've done that in the voltage gain video. In the input resistance video, I didn't do it because I assumed y'all have seen the voltage gain video. And now we have the output resistance, and for the output resistance, we're looking basically we're looking from where the voltage source here is, and we're trying to figure out what does this see. We're applying a test source. We're trying to see what does this test source see. Okay, so first of all, this test source, and I'm going to redraw this so it's a little easier for y'all to see. We have this test source, and we have this test current. Remember, in I was probably like what was it, like circuits 2 or something, when we were applying a test source. Our test source is actually just going to be the voltage divided by the current. So now what we can do, this was before, we're not really doing this anymore because we're doing inspection, but it's a good thing to keep in mind, especially when you have to do small signal analysis. Keep this in mind, because when you apply a test source and you're looking for input resistance or output resistance, and you have to do small signal analysis, you will have to know how to find the voltage VT, that test source, and the current in terms of VT. Anyways, now we have this resistance. It sees RL. And for output resistance, what do we do with RL? Well, we're going to take it out. We are taking out RL in this case, in input resistance and output resistance. If you did Lab 2, you would have known that whenever you're testing input and output resistance, you need to take out the load resistor. I should have said that in the last video, but now you know you have to take this out. It gives you a more accurate reading, so just be careful about what you're going to include and what you're not going to include. So this does not happen for voltage gain. You keep RL in voltage gain, but when you're testing input and output resistance, you must take it out. So now it's here. This sees RC3 now, right? If RL is taken out, it becomes an open circuit, then VT only sees RC3. And now it also sees the collector, because remember, this is a PNP. It sees the collector there, right? It sees the collector of Q3. So what do we have? Well, that means R out is going to be equal to RC3 in parallel, not in series, in parallel, because eventually this is going to get grounded somewhere up there. So technically this node, since they share the same nodes, we'll call this node A and ground, they're in parallel. This happens more often than you think. You have to be able to see this. RC3 is in parallel with RC, right? It's in parallel with this blue RC here. So what can we do? Well, we can actually model this as a voltage source in parallel, of course, with respect to ground, RC3, and then in parallel with RC. And what do we have here? This here is RC. This is a much better way of looking at it. Instead of trying to figure out all of this kind of stuff that's going on, looking at this entire circuit, break it up into steps, please. It will save you a lot of time and a lot of brain, like just brain power. Because in the exam, there are going to be some hard questions for sure. You have to be able to figure out what are the easiest problems for me to do. That way you can get the most points. Anyways, RC, looking into the collector of a transistor, looking at your inspection sheet. If I can grab it without everything falling on me, that would be great. RC here, it's looking into the collector, and we notice, remember, VA is infinity. We have to remember this. So what happens? If you see rule number 3, it says RC is equal to infinity if VA is equal to infinity. I have it backwards, but I'll write it down. If VA is equal to infinity, so we have no early voltage effect, then RC is equal to infinity. So what does that tell you? Well, that tells you this is an open circuit. So what this can be modeled as now is a test source. I'm going to write this a little backwards now. Test source in parallel with RC3 in parallel with an open circuit, which is essentially nothing. So what is R out? If R out is this, R out must be RC3. And this happens more often than not, actually. If you see R out or even R in, where you're looking into the collector of a transistor and VA is infinity, you can then straight away say that RC is infinity, it's an open circuit, so it doesn't exist. Then it's just that resistor. It actually happens quite often. All right. So hopefully this, this video was helpful. At least whenever I'm drawing this out, maybe it helps you kind of visualize what's actually happening versus looking at this massive network of transistors and trying to figure out, well, where do I even start? Because that's the hardest part. So hopefully this helped. If you have any questions, please reach out to me. I'll probably going over, not probably, I will probably, well, yeah, I'll be going over more videos about this kind of stuff, not inspection anymore. But if you want me to do inspection where early voltage is taken into account, please let me know. But hopefully this helped. And thank you all for watching.